Hello, so welcome back to our tutorial on the voltage regulators. And we continue our discussion about what it is and how it works. So in a simplest sense, in a block diagram format, you can expect that the voltage regulator will have unregulated power supply or unregulated voltage at the input side. And you will see that in the circuit that contains the voltage regulator, you will have a series element. We'll see what that series element soon. Then you will have a reference voltage provider. So a block or circuit or a device, reference voltage. And of course, you will then have a load across which you are expected to maintain a constant voltage. So here at the output, you will have a regulated voltage. So what does it means? This voltage is independent of the variations independent of variations in temperature, input power supply, and the load current or the load voltage. So whatever the fluctuation comes or noise or disturbance comes, that may alter your load current, temperature, or the AC line, you will have the constant output voltage across the load. So in a simplest sense, you can expect that you have we have seen that you have this resistance right here. Let's say you have a resistance R, and then let's say you put up a zener diode here, and here is your input voltage V in, which is your unregulated voltage supply, and across the zener you have a voltage drop VZ, and here you have connected your load RL right here, and across which the output VL or V out is your regulated voltage. So this is the very simple form of a circuit, simple circuit using a zener and the resistance. That's it. So when as soon as the V in is greater than the VZ, V in is equal to or greater than VZ, your zener diode conducts a current from cathode to the anode, here the IZ, and the voltage across it VZ, which is the voltage VL, is there. So if there is a changes in the current load, for example, there is an increment or decrement in the load current, the zener diode IZ current gets adjusted, and therefore the total current I, which is let's say IZ plus IL. So if IL goes up or down, IZ goes down or up respectively to maintain the same current IL. And accordingly, you see that the VZ is always constant across the load. And that's how you maintain the output voltage constant irrespective of the changes into it. Now there are types of voltage regulator. So the first one is called as series regulator. Second one is called as shunt regulator. So we'll see in a moment what these are. And these are the types of linear regulators. And the second category is, so let's say this is the part A, and the part B is called as switching type of regulator. So you use the switching element. So these are the types of the voltage regulations. So we would like to remind you that we have seen in the block diagram, in case of a voltage regulator, you have this series element right over here, and you have a reference voltage, for example. So let me draw it properly. So this is actually the complete circuit that will have that. So you have this series element, you have a reference voltage, you have a load here, and you have an unregulated power supply. So let's first understand with this block diagram, you have this circuit representation now. And in this circuit representation, you see that this is your series element that is in the form of a transistor. This is your reference voltage provider that is in the form of a zener diode. That's your load. And this is your unregulated power supply. So this is a classic example of linear regulator circuit. And in that, it is called as series regulator. Just we saw that in the previous slide. We saw that here you have series regulator, you have shunt regulators, and these are two types of linear regulators. So we come back to our discussion. So what you see here, you draw a current I from the unregulated input power supply, and that current is being coming to these two parts. So let's say this is IR1, and this is your emitter current of a transistor. This is an NPN transistor where you have this is actually a collector current IC, and this is your collector, this is your base, and that's your emitter. And the current coming out of the emitter is your IE. And furthermore, IR1 is getting split into two parts. So this is your base current, and here is your zener current. That is the current flowing through the zener diode. Now this IE is same as your IL. Okay, and the voltage drop across the base emitter junction, that is this drop, positive and negative. So it's called as VBE. So the working principle of this circuit is quite simple. So let's say you have an output voltage, that is the voltage across the load, which is the voltage VL. This is VL. This tries to goes up. This goes up, and therefore the voltage drop across the base emitter junction VBE goes down. So let's say as VL goes up, VBE goes down. So if VB goes down, it means it's a control voltage of a transistor. The IB is made less. So IB decreases. So this action is IB is going down, and IB goes down. It means you have less emitter current. So remember, IE is equal to IB plus IC. That's your transistor current equation. So again, VL goes up, VBE goes down, IB then goes down, and IE goes down. So IL goes down. So if IL goes down, it means the drop across the resistor RL, which is VL, goes down. So that's how, because the VL is equal to IL times RL and IL is equal to IE. Now, in the second scenario, if VL goes down, this leads to VBE goes up. This leads to IB goes up, and this leads to IE goes up. So VL therefore again IL times IL RL right here, and IL is equal to IE. Therefore the BL will come up. Okay, so that's the kind of feedback action it is maintaining. So you can actually see that you can apply the Kirchhoff's voltage law in this loop to make this voltages. So let's say plus VZ minus VBE is equal to 0. So you have a VO equal to VZ minus VBE. So that makes sense. So your output voltage will always be zener voltage minus 1 base to emitter junction drop minus the base to emitter junction drop. Okay, so that's your output equation. So remember VO is equal to VL. So this is how the simplicity of the circuit works. Other current equations also can be made. For example, you can apply the KVL in this loop for the input side. So here you have V in minus IR1 into R1 minus VZ is equal to 0. So while designing this circuit, you can express yourself in this equation. So we have seen like how series voltage regulator works here, and how the circuit functions and automatically regulates the output voltage. So there is a changes in the load voltages due to temperature, for example, or fluctuations in the input side. You will have the transistor, series pass transistor, that is taking the control, and you are getting the load adjusted, and the zener is actually reference voltage provider. So output is essentially VZ minus VBE, one drop less. Hope you understood this video and its content, and if you like that, share it with others. If you see something about it and you feel like, you comment it in the comment sections, and like and subscribe to the channels, and do share with others. Wish you happy learning. Stay tuned for more informative contents on these voltage regulators. Wish you happy learning.